UNBLACKFACE Bassman. This belongs to my friend here, Bob, who has a YouTube channel. You guys might recognize him, Bob Bradley. Tell me what's going on with it, man.
All right, 66 Bassman. It's really quiet, almost like output transformer or something like that. Now, normally I would take all the tubes out, put different tubes in, bubble around inside of it until I got frustrated.
Yeah.
But this time I thought I would just forego that process and
just
bring it to
let a pseudo professional take care of it, huh? What's the story with it, man? It's clean.
It's clean, but somebody's been in here.
Okay.
I did open it when I first got it, and somebody that's not very good at soldering is messing. So
that's a good thing and a bad thing, because that might actually spell a good thing for the the transformer.
Yeah, absolutely.
Like your suspicion of the transformer, it's probably more likely than one of their mistakes.
Yeah, hopefully.
Yeah.
I was kind of thinking that, and I know I've seen some of the stuff that you've done, and it's beautiful stuff. So I just thought, yeah, Brad's the guy for this.
Do you want mods or do you want stock?
Well, I don't know. I think
you don't know?
I think you should look in there and see what this. If the output transformer's bad,
yeah,
I'd be more open to mods.
Right. Makes sense.
What I'm saying?
Perfect sense.
But if it's pretty much just like some stupid mistake some guy made, or just like a cap or something, I probably just want to keep it like a Bassman, you know what I'm saying?
For sure. Yeah, I mean, can't go wrong with a Bassman. Well, tell me about what you do on your YouTube channel. While we got you here, man.
YouTube channel, Bob Bradley channel. It's a music channel. Lots of guitars, vinyl, other cool stuff, turntable, stereos, things like that. We're out there looking for cool guitars, looking for awesome records, looking for cool amplifiers. And
well, speaking of records, man, if you want to go through, you're welcome. You're welcome. All right, guys and gals, let's take a closer look at this super clean looking Bassman together. Very few scratches or dings on the faceplate of any kind, and no real rips or tears in the Tolex that I can see. Maybe a couple little small ones. But whoever owned this thing probably kept it in the closet most of its life. The grill cloth looks to be original and in pristine condition, although a couple of the knobs look like they've been changed. Someone has definitely serviced this amp at some point because the power cord has been changed. I'm going to shut up here for a minute and let's pull the chassis and admire this thing in silence. Okay, so I decided to come down here, plug this thing into a cabinet to kind of get a better idea of what it's doing, and yeah, sure enough, it's got problems. Let me show you what it's doing if I can. Right now it's kind of loud because I tapped on the top of it, top of the amp, and it got a little bit louder. Right now it's louder than it has been, but it's like it's all treble though. It's weird. Popping and crackling. Seems to be really loud when I hit the doghouse for some reason. What the fucking hell? We got either it's a loose connection, maybe bad tube, but yeah, I wanted to get a better idea of what it's doing, so now I kind of know it's. And when I first plugged it in, it was really quiet, like Bob said, it was just really low volume, and I tapped on it just like I did a second ago, and it actually brought out the volume, but it's still doing all this mess. So I think we probably got some either loose components or we have a bad tube possibly. Okay, so I'm in here looking at this circuit, and this thing has got some major differences from both the AB165 and the AA165. Now, of course, these two versions of the Bassman are themselves quite different from one another. You can see all these little circles that I've made on all these components here on the schematics, and these are pointing out all the differences between the two versions of the Bassman, the AA165 and the AB165. Well, neither one of these schematics conforms to what we have here, particularly down here in this area. Somebody has really come in and done a number down right in here on the phase inverter section. It looks like, at least that's what I'm thinking we're looking at on all this. I have to go through this because we're not anywhere near either one of these schematics. This is all different than both of them. So I'm gonna trace some things out and try to figure out where we're having issues, where it's going awry, I guess I should say, from the schematic. But just I'll give you an example here. Look, if we look in this area, you'll see, so here's the 12AT7 phase inverter. On pin 2 of that, we've got the screen of the first half of the tube coming to this point. We have a 1 meg resistor here over to this little central point, and then coming off of the other grid over here, we have another 1 meg resistor here, and then the cathodes are tied together coming to this third point in the middle, which has, it looks like a 470. So if we look at this part of the schematic, we can see we do have the 470, we do have 1 meg and 1 meg. But right over here next to this 1 meg, you'll see there's a 500 picofarad capacitor that's supposed to go from this point to this point. That's this capacitor right here. So this is supposed to be a 500 picofarad capacitor right there, but we don't see it in the amp. It's not here. There is a capacitor here, and I'm guessing that's probably a 500 pico, but it looks like it's in the wrong spot, at least according to the layout. Let's see if we can measure this in circuit. Maybe we can, maybe we can't, I don't know. It's not wanting to measure that in circuit. Let's see where this is going. Is it just tied directly here? It is. So there's a short from here to here. So there's a wire running under the board from this point to this point. But in series here, we're supposed to have a 500 picofarad capacitor and a 220K resistor. And if we look back over here at the layout, that should be, yeah, there it is. See there? So we have the 500 picofarad capacitor and the 220K resistor right there. It should be in series, but it looks like they've dispensed with the 220K resistor and they've placed this capacitor here instead. Why? I'm not 100% sure. Well, in the AB165, they have a 0.1 capacitor right there instead of a 500 pico, and there is no 220K resistor. So they've dispensed with the 220K and given us a capacitor here, again, the value of which I really can't read. That's kind of too small for me to even see, and without pulling a leg, I don't know what their value is. Let me see if I can see it here. 103K, so that's a 0.01. So it's not like the AB165 or the AA165. It's kind of in the middle of those two values. Yeah, I need to go through this and I need to figure out what all is going on here. So anyway, that's just one example of the differences here between the two schematics, but I've got to look over the rest of this here. So here's the junction of those 3 resistors we were talking about a minute ago right here, and that corresponds to this junction right here. Well, if you look, there's only one component coming off of that junction. That is a 22K resistor coming off of that junction right there over to this point. But in this example, we see yeah, we see a lot of big differences here actually. What is going on with this thing? What have they done here? Man, see, this is why I can't stand getting something that somebody has already worked on without providing any documentation or schematics or whatever. You know what I mean? It just makes it really doubly difficult. But this area right here is not correct. There's something's way off. Really, with all of this is all way off. I probably should just rewire this to one or the other of these schematics and be done with it. But I'm going to try to analyze what they were going for and see what we can ascertain about it. But I mean, yeah, even if we look at that junction right here, again, there's only one component coming off of it, and that's going over to another point over here. And again, that looks like another 22K resistor. So there should be only a 22K resistor coming off of the other side of that. So these are the 3 components right here. There's the 1 meg, there's the 470, and there's that 1 meg. Coming off of that on the other side, there should be only a 22K resistor. separated from ground by a 100 ohm resistor. And then we have a 0.1 capacitor from the 1 meg spot. Let's see. Yeah, and there's no capacitor up here either. There it is. That's it. Yeah, we do. But where's that going? Why is that going over to there? Are they using this as a ground point? No, separated from ground by 4.6 K. What about right here? That's the ground point. Right there. So we're coming to this point here, separating from ground by this resistor. There should be from here to here like a 100 ohm resistor. In the AA165 should be that resistor right there. And instead of that, we have a 4.7 K. Let's see what we got over here. On this one, we have nothing. It just goes directly to ground. What the hell? What the hell, dude? All right, I got to figure this out. This is entirely wrong, and we're gonna work on this. Okay, we're gonna fire this thing up for the first time on the Variac and take some measurements and so forth. Let's see where we get to. I've got a signal into this bass instrument channel, but we'll go ahead and dial it up. I'm really curious to see where things are kind of sitting here. Go to about 75 volts on the input and hold off for a sec. We got nothing. Why do we got nothing? I mean nothing. Okay. There we go. There's something. Okay, I just kind of moved the board there, and my waveform is distorting just from moving the board. So we've definitely got some connection problem here somewhere. Something ain't right. I think also our bias is set too low, because we're getting all kinds of crossover distortion. We're getting crossover distortion well before it reaches maximum amplitude on the waveform. Like we've got crossover distortion, yeah, way down on this thing. I don't know what's up with that. See anything? I don't see anything. I thought I did for a second, but now I'm second guessing that. Let's increase the voltage. Go ahead and bring it all the way up to 120 volts on the input. And we'll just kind of see what that does. Yeah, we have some asymmetrical clipping here. See that? Right there? Look, that's just from pushing on this. Pushing down right here on this spot. Whoa, whoa. And it completely cut out. Did you see that? So I pushed down right here on the board and it completely cut out. I think there might be something blob of solder or something underneath here touching. Actually, what the hell is that? Oh, I think they even knew about it. Look, they even knew about it and put something under there. Look. Look at this. So, whoever's been in here before me knew about this issue and put some kind of little plastic poker chip or something under here to keep it from shorting out. Look at that. See that? Maybe a pick? Is it a pick? That's exactly what it is. Look. So, okay, whoever did these mods put something underneath there to keep that from shorting out. It was a known issue. So, we need to pull this whole board. We're going to have to pull the top and the bottom pieces of this board. This is not going to be fun, but it's got to be done. It would really be nice to be able to do this without taking all the front controls off. At least it's a Bassman. That means fewer controls, but still, I don't want to have to take all these off if I can keep from it. Let me see what I can see just lifting this up though. These boards are in two different pieces. There's a top wafer that the parts are mounted to, and then there's a bottom wafer that keeps the components from touching the chassis. Well, obviously that wasn't happening. Something is touching the chassis, and I think I am going to have to take all these components off the front here. And just another observation, it looks like all of these pots are new. Good God. Damn. Somebody had those on there. Yeah, that's kind of what I thought. We've got ground connections over here. I can't really see under it, but I can feel under it. Reaching right here, there is a wire that's running from here to somewhere over there, and there is a real spiky connection right here. So I'm thinking maybe that spiky connection was going through that lead. Yeah, it's exactly what they did. They stuck that up under there trying to get that to stop happening because it was shorting out. I'm gonna need to lift this whole ground bus. So in these old Fender amps, there is a ground bus that runs the length of the front panel usually. All the input grounds and everything are attached to it, and all of the grounding for all along the line. Every place where the components meet at a ground, there are wires that run over to that ground bus. And it's made of brass. It's like a bent piece of brass shim stock up in here. It makes the ground more reliable. You know, a ground point over time can kind of be less than ideal. But here's the bus. I'm gonna have to undo the bias control too. Well, we've got a ground point coming out of the. I'm gonna have to loosen one of these anyway. There we go. Okay, now she ought to come up. Let's see. Well, let's say that, but this ground right here is running up underneath all these wires, so plus this one here for the bias. There we go. What else? This one for this ground over here. Okay, that was barely on there. Basically all of these wires are holding this up. I got to take this ground off right here too. I need a different soldering iron for this right here. This is not. This ain't really cutting it. Okay. What else? I'm gonna have to take these two wires off also. So I've got a white wire running to here. Okay, and I've got this black wire running to here. Okay. Is that it? Nope. Not really. I've got a wine colored connection going here. So that's coming from one of the nodes of the power supply. This is another node of the power supply. This is the white one coming to this point. Okay. And then the red one is going here. So this is all power supply nodes. Alright, now let's lift this sucker up. So again, I was pushing down in this area, and that's where that little piece of plastic was too. Let's see what was going on over there. No, nothing was going through the board. It had to have been shorting from one connection to another. And what I'm thinking is we had a short right here on this wire. See this wire right here? This one running across here is going directly across a couple of different connectors. Yeah. See right here? This is always kind of an issue when you start to solder around on stuff. You start soldering and you see how they've soldered right onto that wire right there. We had a short from one of these connections onto that wire probably, or it could be another one. I found another one over here too. It was this wire right here also was going right across this little sharp bit a second ago. That's interesting. Look at how they marked this. You see all those yellow marks on the board? They've got all these yellow marks on here. Those are for, what is it, installation of the parts or to help the people assembling these? I don't know if I've ever seen that or not, but you can see what they've done. The whole board has those marks all the way over here, like little yellow markings showing, basically following the path of all of these wires underneath the board. So maybe this was a way that they were checking them. This right here definitely has to be, it needs to go somewhere around these connections because it was right on top of them. And you know, when you solder down onto that and you stick a component in, that component's leg is going to stick right through that, and that's what was going on, I'm pretty sure. Okay, so I've got this board fastened back down now and got it plugged back in, and I'm getting some strangeness here. Look at this waveform. Playing with the treble here a little bit, but that waveform is not right. Something. Okay, now see, that went really quiet there. Okay, so that's what we're looking at through the output. Instead of looking at the output, let's grab our probe. Let's instead start probing around here. Okay, so we've got something there, obviously, on the input. So yeah, that's what we've got on the volume pot. It's jumping around in amplitude, I don't know why. Oh, you see that moving? You see when I turn that volume pot like that? You see how that DC offset is kind of moving? It's moving around, kind of moving up and down. That tells me we might have a bad capacitor here. One of these capacitors might be bad. That's a smoothing capacitor for the power supply. So we've got 240 volts right there. Then it should step down a little bit. It does to 159. Let's see what we got on the cathode of this first tube. 1.3 volts. Yeah, that's in the range of what we should be seeing there. Let's see what we've got here. That's 157. So that's before the plate resistor for this first half of the tube. Okay, so this point after the plate resistor, we're getting 159. There's 157. So, right, and then it'll go into. It's going into several capacitors here. Uh-oh. Did you see that? What happened there? Did I blow a fuse? I think I must have blown a fuse because I was getting nothing here. It looks like I did. Looks like I did, thankfully. Why did I just blow a fuse? I might have to back that up and see what caused that. Maybe it was something to do with measuring these plate voltages, because that's what I was doing. I was measuring plate voltages. I don't know why that would have blown the fuse. That doesn't make any sense. But let's see what fuse this is. This is a 2 amp fuse. Isn't this supposed to be 3 amp? No, 2 amp. Slow blow, yeah. I did not fail to hook any wires back up or anything that I could see. I don't know, maybe replace the fuse and do it again. Did I forget to hook up bias on this thing? I don't think so. No, it's hooked up. Isn't it? Or no, wait. Wait. It's not. There's no bias hooked up. That's why. Shit. Okay, that's why. Yes, I did forget. I forgot a lead. I forgot to resolder the bias. Did not attach the bias. I believe it. All it did was blow a fuse, so we're at least good there, I think. I don't like to disassemble amps too much if I can keep from it, because it's, you know, you run into little things like that where you forget to put everything back exactly where it was. Well, I got 90% of it, but I don't know if I could have picked one that would have been worse to forget, though. Maybe one of the power nodes, like if it was just hanging there. That would have been sparky, maybe. Now we probably will see some better stuff. Let's try that again, folks, shall we? Let's do that again. The difference between me and the other amp people who do this all the time on YouTube is that I show you my mistakes, and some of those people don't. Now, a lot of them do, and they do a great job, but a lot of mistakes get canned, and mine usually don't. So the only reason I would ever erase a mistake out of one of my videos is if it was in the process of going down a rabbit hole that, like maybe a section, like maybe I spent 30 minutes looking into something that was a red herring. So, you know, if I make a mistake on the way of the red herring, maybe I'll erase all of that because none of it's really relevant in the end. But usually I'll leave my mistakes in. Anyway, all right, here we go. We'll go back up to 80 volts. 82 volts in, and we're at 0.39 amps of current, and that's holding pretty steady at the moment. So I think we're good there. Let's look at some voltages again. So we've got voltage there. Let me see here. What we got? Anything there? No. Ooh, did you see that? We had 14 volts on the other side of that capacitor. We have 156 volts on this side of the cap, and that voltage right there, it's waning away because I'm draining it, but there was a lot of voltage first before these probes are actually draining the built up voltage on this cap. But it's over a volt when I first put my probe on this. This cap is bad right here, this one. So we can go ahead and dial it up, I think, now, because we've got our bias voltage back. So let's go ahead and do that. Let's dial it on up to 120. I think we might have solved this thing's problems. I think we had a short underneath the board, and that's what was causing the problems. You can see how this thing has a slight bit of asymmetrical clipping, because it starts clipping on the top of the wave before the bottom of the wave starts to clip. But right about here where it starts to clip, we're already seeing the crossover distortion there. I sent the owner of this amp a message asking him if he wants me to include, because there is a unused half of a 12AX7 in these Bassman. The AA165 and the AB165s, they have an unused half of a 12AX7 just sitting there waiting to be exploited. I've made videos about this before and doing some mods that make one of these things scream, and I'll put some links up here if you want to see those mods and how to do them. I did send him a message asking him if he was curious, if he wanted me to. I can actually use that other half of that 12AX7 and make this thing a rock and roll machine. I'm kind of crossing my fingers hoping he says yes to that, because it would be really cool. Yeah, that bright is adding a lot more noise. That's because the bright that bright cap will actually the bright cap will actually introduce some noise, because it's getting it, like, it's introducing high frequency radio. RF is what it's doing, especially when it's out on the desk like this, unshielded. It'll introduce more of that. That's why it's kind of getting noisy when I turn the bright switch on. But turning it off, the wave looks pretty clean. We've got to do something about that bad capacitor. Here's the thing, my philosophy on these. When I get a bad molded capacitor like this, and that's bad. You see that? You see how that started out at 10 volts? It actually was, no, it was higher than that. It was at 12 volts. When I first put my probe on that, it's 12 volts. And then it quickly drains as it's being measured. But that is a bad capacitor. And here's the thing, okay? This is a controversial approach for some, and I've never really understood why it's controversial. But for some people, apparently it is. They'll say, why are you changing stuff if it doesn't need to be changed? Blah, blah, blah. Well, my argument is that they do need to be changed. This amplifier is from 1965, 1966. All of these capacitors have been exposed to all the same conditions, all the same environmental conditions since 1965. We already know that this one is bad, that something has happened to compromise this capacitor right here. It's leaky. The rest of them don't measure leaky yet, but because this amp has a capacitor in it that is measuring leaky, and the rest of these capacitors have been exposed to all the same conditions, my approach to this is to always just change all of them. These aren't that special. I don't give a damn what anyone says. These little molded blue capacitors like this, that's not the secret to Fender tone. That has nothing to do, virtually nothing whatsoever to do with Fender tone. Nothing. And anybody who says otherwise, I think, is absolutely full of it. They're trying to sell you something. I use inexpensive capacitors usually to replace capacitors like this, but I can offer a range of things too. It doesn't really matter. And they're cheap. It's not like I'm making a lot of money replacing those capacitors. That's not the reason I would do that. You know, I'm not trying to swindle anybody or anything of the sort. I'm just saying that when you get a bad one, if you don't change the rest of them, you're going to regret it. And I'm going to get in touch with the owner just to give him the option. My approach is always to try to convince the owner in a case like this to go ahead and shotgun those capacitors. Like I said, I can replace them with something that's going to work just as well, actually better, for longer. Why this thing has been so heavily serviced already as it is, and I've still got some other service that needs to be done to this thing, I really think it's for the best to just knock it out. So what I'm going to do for now, I'm going to shut it down, leave it for tonight, get in touch with the owner of the amp, and then we'll come back to this thing. Yo, what's up, Bob?
What's going on, dude?
I found the crux of the problem with this amp fairly quickly. It was a wire underneath the board. Whenever the board flexed or whenever the amp moved, it was stabbing that part lead down into the wire underneath the board is what was happening. So I've got that all fixed, but these blue molded caps that are in these amps, one of these is leaky like a sieve. It's leaking DC across it.
Really?
Yeah, but yeah, usually when one goes, man, I usually just replace them all, because if you don't, it'll end up back in here.
Well, I mean, Brad, you know better than me. You know, I mean, I'm cool with whatever you want to do.
Some people are just persnickety about the old caps, and I mean, with ones that are leaky, it's not going to help you any. You're looking at like under $10 to replace them. I mean, it's.
And what are you going to put in there? Jupiters? I mean, what? No, I'm just kidding.
Well, I mean, I could order those if you want, if you insist on that, but no, probably just some Panasonic style poly caps. Just something real simple.
Okay, whatever you think will sound appropriate is probably whatever we should do. Well, what do you think about that bass channel?
This is an AA165. There's an AB165 also, and one of the main differences is they moved where the normal channel ties back into the bass instrument channel. Put it this way, on the AB165, it has one extra gain stage on the normal channel than the AA165, which is what you have anyway. So I could move that and add one extra gain stage on the normal channel anyway. And what that's going to do too is that's going to make it where you could jumper channels. We could do it that way, or the other way to do it would be to add, this is the way I suggest, and this makes these into a monster of an amplifier if you wanted to go this route. Add that unused gain stage onto the normal channel, and then you will have 3 gain stages per channel, and they'll be in sync, so you can also jumper channels, but instead of having 2 gain stages per channel and jumper in the channels, you would have 3 per channel, and you'd be able to jumper channels, or you'd be able to ABY box into one channel and the other and switch between them. And then the only thing to do after that would be just to add if you wanted to, is to add a simple master volume on the back of the amp where currently the old switch is for the ground, because you're not using that anyway. That's been taken out of circuit, and it would be on the back of the amp, and it wouldn't no extra holes.
That's like, no, let's not do the master volume. But
okay,
I'm cool with just doing the gain stages on the channels, and being able to jump them for sure,
Okay, well, which way do you want to go? Do you want to go where we add the unused?
Well, let me ask you a question. Is it going to sound dramatically different than just like a typical Bassman, or what?
They've done a lot of mods on it already.
I was going to ask you.
Yeah, there's been quite a bit of modding on it already.
I don't remember me telling you this, but it was like I was telling you, it was super loud sounding when I was playing through it. It was the normal channel was crazy loud. On one, I don't know what they've got, what kind of mods they got going on, but it's, it definitely wasn't like a typical Bassman. How are you going to approach that?
There's a tiny 500 picofarad capacitor before the phase inverter, and they've changed the value of that, and that's probably adding a lot of gain to it. And if you want me to quiet it down, I can do, and tame it down, I can do that. If you want it tamed down, I can do things to tame it down and make it cleaner, if that's what you prefer.
No, it was fine. I just felt like it was super low. Like 2, it was as loud as my deluxe reverb all the way up or something,
Yeah.
So, I don't know, maybe I just hadn't heard a Bassman in a while, but really, I think whatever you think is best, Brad, I'm down for whatever, actually.
All right, man, you said it. I'm going to turn this into a diesel, and maybe let me get it up on the cabinet again, and I'll maybe have a better assessment of what ought to be done.
Yeah, just hit me up after you play through it or whatever and tell me what you think about it.
Okay, yeah, will do. Okay, guys, in the interest of brevity for this video, because it was going to be probably 2 hours long or more if I followed everything that I've done with this. So I've skipped ahead quite a bit. In fact, I've skipped ahead pretty much to the finale of having this thing done. But I want to tell you why I skipped ahead, because it took me so long to kind of trace out and figure out which of these schematics it was that I was dealing with here. Of course, it says AA165 on the tube chart on the actual amplifier physically. I did go through and identify some of the things that are in here correspond to the AA165, and yet other things correspond to the AB165. So it took me a while to figure out this is some kind of transitional model between the AA165 and the AB165, which I'm pretty sure came later. This was a bit of an odyssey that I'm just going to frankly spare you most of it. So, like I said, we're done. This thing is completely rewired, reimagined, ready to go back to the owner and ready to rock the F out, because, man, this thing, I tell you what, I've tested it on a 412 cabinet, and I have to say it's magnificent. This is an awesome amp. And if he doesn't want it for some reason, I will buy it off of him. Because this thing is truly, I mean, you're going to see in the demo here, I'm sure, coming up. But man, you know, I've tested this out, going back and forth, carrying it up and down my stairs to my basement studio, testing it on the 412, coming back up, making slight changes, readjustments, going back down, coming back up. If I had filmed all of that once again, this would have been a 2.5 hour long video. So I'm sparing you all of that, and what I'm going to do instead is give you a rundown, sort of a synopsis of all that was done here. You see here that the cable coming in has been rewired. All this stuff has been rewired over here. There's less here. There was a switch right here. That switch was for the ground lift, which was removed. The death cap was already removed, so I went ahead and took the switch out. Along with, as you can see there, all the blue molded capacitors. We've got them in here too. So those have been removed. One of them was bad, at least. The other ones probably would not have been far behind, so I just advised him and he agreed to change all of those blue capacitors. Now, some of you guys are probably gonna start screaming about that. Oh man, blah, blah, blah. Well, shut up. You're wrong. When one of those blue caps goes bad, the other ones are probably not far behind, and it's best to go ahead and just bite the bullet and get them out of there and put something that is electronically sound in there. So as you can see here, that switch was removed. In its place is the 1 meg volume pot, which originally was up here on this volume for this channel. I removed it, put it back here as a post-phase inverter master volume, and this is the type 3 master volume from the Trainwreck pages. This is the simplest master volume pretty much that there is to do, and all it does is it takes one side of the output wave and mixes it with the other side of the output wave on the two that are going to the two grids for the outputs. It's mixing those two grids together when you turn the pot, and it is phase canceling them out to the point where if you turn it all the way, then both cancel each other out completely. It's not completely transparent, but when it's all the way up, it is near enough to transparent that no one is ever gonna know the difference, period. This does nothing pretty much when it's all the way up. As you start turning it down, yes, it's gonna attenuate the signal, and it's actually, when you get really low, it's gonna start to sort of distort the signal. I could even show you that on the oscilloscope. It does distort it somewhat, but some people actually might find that to be a good thing. So I like this style of master volume for the post-phase inverter. Main reason is it doesn't fiddle with your bias supply voltage. Some of the other master volumes post-phase inverter are fiddling with your bias voltage, and if something goes wrong with that, with the wiring on your new master volume, it can cause problems and cause the tubes to run away. And you know, this is a much safer, much easier to accomplish, and in my opinion, sounds pretty damn good anyway, and it does the job in this amplifier. So that's what we've done here. We didn't drill any extra holes. If he wants to return this to stock, he always can do that if he wants, but nobody is ever going to want to do that, I guarantee you. There were two orange drop capacitors, these two here. So these were 0.1 capacitors going into the 6L6 grids. I have changed those to a 0.022. So I moved, now these were some of the few components that were AA165 spec. I changed those to 0.022, and he had a 0.1 capacitor in this position and on the stage before for the coupling, and I changed that one to a 0.1. What else? Okay, so the bias was already set to, when I found this at least, it was already set to the AA165 spec, which I prefer. In the later version, this becomes more of a bias balance pot rather than a true bias pot. So that was already AA165, so I left it. Now, on to my big mistake, which, well, I say big mistake. It's not really a big mistake. It doesn't matter at this point. But I started to wire in the third, this extra gain stage, which was blank from the factory. You know, there was nothing on this half of that 12AX7 right there. Well, I went ahead and wired it up so that the normal channel, starting here, this normal channel, would go into that stage first, and then come to here, and then go into this half of this 12AX7 on the V3 tube, and then on from there. So we would have 1, 2, 3 stages. Well, little did I know, it was already 3 stages. So this is what I'm talking about. Half of it was still, or was already, the AB165 spec. And it had the 1, 2, and the third stage was this one that was shared between the two. So there were already 2 stages per channel, and then this stage right here was shared. So they were already in phase. It could have been jumpered already, but what I ended up doing was when I added this third stage here, I just went ahead and made these 3 stages independent of these 3 stages, and none of them are shared until the phase inverter. So that's what I ended up doing. So yeah, so that's essentially what we have here. We have a situation where on this channel, on the normal, signal comes in here, comes to the junction of these 2 resistors. As you can see, there's a shielded cable. I added a shielded cable because I wanted shielding for this long cable run that goes from here all the way over to here. So it goes in here, comes out of the and actually I had to create a supply for this, for the voltage. So on the plate, if we follow this over, that comes to this point right here. I also added this terminal strip to put some components, extra components here, so I wouldn't have to have them flying in midair. So it comes to this point of the terminal strip. As you can see here, here's an additional plate load resistor to supply the plate voltage, and I made it a metal type, and it's getting its feed from this node right here coming on this black wire. So there's that. Also, we have a capacitor coming from here over to here, and that is a 0.01 capacitor. There is a grid stopper resistor of 100K. The grid leak resistor is also 100K on that. Now I experimented up and down with different values on that grid leak resistor for this stage, and found out that 100K was about right once I got everything else dialed. Now it took me, like again, it took me some experimentation. To bias it, I biased it with a 2700 or 2.7K resistor, and kept the 25 microfarad bypass capacitor for that stage. Oh, and by the way, on the first stage too, I biased it with also with a 2700. So on this normal channel, all 3 of those first stages are biased with 2700 ohm resistors. So I had to bump up those, trying to get everything, because what I wanted to do was I wanted to tastefully stage the gains from one stage to the next so that it cascaded more smoothly and that we didn't get blocking distortion and all that sort of thing. Because at first I was getting at first I went, with the maximum stuff, I went with like a 1 meg grid leak resistor there, ground reference. Went with like a 1K resistor for the bias, which was like way too high. It was over the top. So I got out my resistance load box and started clicking through, and found out that the higher I went, the better it was actually sounding overall. And I kind of settled on changing all 3 of the stages for this channel to 2700s for the bias resistors. That's essentially what I've done on this channel. Oh, and also on the bright switch. Now this channel is really a lot brighter now because I used 0.68 microfarad bypass caps on the first stage and also the third stage. On the second stage I went, and this was after some experimentation. At first I had nothing there bypassed. So I was trying to keep it brighter. I was trying to make this channel the bright channel, basically, and make this channel the bassier, Bassman-ish channel over here. But come to find out, this really needed that 25 microfarad, so I bumped up a little bit more bass on this channel because it kind of lacked some, so I went ahead and went back in and put that in there. As you can see, there's an empty eyelet right here. There was a local feedback resistor going from here to here. This one was a feedback resistor. I removed it. Now, it might seem counterintuitive to remove that because this was on the bass instrument channel, the one I wanted to keep most stock. But these feedback resistors, what they tend to do, and this is the problem I have with them, they tend to take away some of the attack on the notes, and what it does is it makes the amp kind of sound more refined and more cold in a way, if that means anything to you. I like the fact that without it, it has a little bit more of an attack on the notes, and it's fairly impossible to describe it. You just know when you hear it. Oh, also, like I was saying, the bright switch on this normal channel. So this bright switch right here, as I've done in the past, what I ended up doing on this is making this into a mid-range switch. So this will give you a choice of two different mid-range structures. If we look at either one of these schematics, because they're both the same on this section of the schematic, this 6 point whatever that is, what is that, a 6.2, yeah, 6.2K resistor, I have made this into a 215K resistors in parallel. One of them is always engaged and the other one is on this switch now. So I've got one of the 15K resistors from here to ground, and the other one is right here, and its grounding gets engaged. You can see the blue wire, it runs over here to this point, and this resistor gets engaged with the flipping of this switch, and what that does is it changes from a 15K resistance, which is a fairly high, it's kind of like if you took a Marshall almost and you know, cranked your mid-range up quite a bit. So it goes from that, if you want that more Marshall-y drive to this channel, you can get it. And the easiest way to get it is to flip that switch into the down position. That's going to give you more mid-range. Flip it up, and that engages this second 15K in parallel, so you're getting something closer to what the original 6.2K resistance was. So the channel is more stock when it's in the up position. I think that this is a good mod, and it's a fairly easy one to do, and it's an easy one to undo. Even if you like your Bassman stock, the bright switches on these channels rarely for me do very much. I mean, it doesn't do anything that you wouldn't really get in spades if you just crank the treble anyway. I think the bright switch is unnecessary. Having the choice of a mid-range contour is way more useful for most players than having a bright switch right there. I think Bob's going to agree when he plays on it eventually. But this is the thing, people don't know what they want or need until you show them. Take it from me, you need this. you don't know you need it, but you need it. So anyway, those are mainly the mods and everything, and the work that was done on this. Also, wow, that was a heck of a... We have had just nothing but constant rain. Bill Gates must be out there working overtime with the whole weather modification thing right now, because we have had days and days of rain straight. They've flooded in Texas. They flooded New York City subways. We've been getting nothing but constant rain here in the middle of the country. In Louisville, Kentucky, it's been pretty constant for days now, and it's projected to keep going for several more days. My neighbor just mowed his yard today because it was the first break in the weather we had, and now it's back to raining again. So, you know, like I said, weather modification probably all day long. I'm sure these are not unprecedented rains by any historical stretch, but at the same time, I don't remember seeing like 10 days straight of rain for a long time. Not in my recent memory, so whatever. Anyway, so that's what you're hearing in the background. This right here, this clamp wasn't really closed all the way. That's another thing too. He still has some old Svetlana, made in Russia Svetlana from 1998. Look at there. Look at here. That's what he had in here. Svetlana's from 1998, the 40th week. Man, these are old school, great tubes. I wish these were still made, man. These were excellent tubes. It's very good to see. I remember when they were selling these, and I wish I'd bought a ton of them back then. I think I installed some in my Carvins that I had at the time. Anyway, so those are still perfect tubes, perfect output tubes, and they sound freaking killer. But his preamp tubes, okay, so he had a couple of JJ 12AX7s in here. He also had a single RCA 12AX7 and had two JJs here in the V1 positions for the channels. But it was way too much. You know, what I like to do on my mods, when I do a mod, I like to mod it to the point where, okay, this thing is about to go wild if you crank everything up all the way. Like if you get all the controls all the way up, it's too much at that point. You know, and you have to back off a little bit and find your tone in the amp. I would rather do that and have the option to go buck wild at the top end of the range than not be able to get there at all. Do you see what I'm saying? So this amp, you have the range, you have the capability. If you wanted to pop 12AX7s back in this thing, you could. But right now, what I've got in here is an RCA 12. These are all hand selected too out of my stash. So I went through and I tube rolled for about a good hour doing this and found some really nice tubes that sound freaking phenomenal. So I've got an RCA 12AU7 in this position. I have a Sylvania 12AU7 here, which was new old stock. I have a this is a Magnavox labeled. This is from my personal stash. This is a Magnavox labeled 12DW7. This was also made by Sylvania, but the DW7 label is rubbed off of it. But a DW7 is basically it's one half 12. What is it? It's one half of a 12AX7 and one half of a 12AU7. I'm pretty sure. I think that's the case. Like I said, I went through and tube rolled and found the ideal set of tubes for this. And like I said, again, 12AU7, 12AU7, and a 12DW7 for this stage. And if you wanted to go with like another 12AU7, you could actually make the amp a little cleaner and give it a little more clean headroom and stuff like that if you wanted to change that, swap that one right there out for another 12AU7. But I'm going to mark this chassis with some sticky labels so that in the future, anybody who comes in here changing these out will know what belongs where. When you sit down with an amp and you lovingly go through it, most techs, man, their goal is to make it work and then get it out the door and get something else on the bench. That's never been my goal. And I'm never satisfied with just doing that. I don't like to just, okay, it's working now, there's nothing more I can do. I like to try to do my best for the customer, give them back something that I can be proud of, that they can be proud to own, and they can be proud to play on stage and say, hey man, listen to this thing, to their best friend. You know, somebody in the audience who's also a gearhead might look up on stage and see a Bassman and be marveled at the fact that he's getting that tone out of a Bassman and be like, man, that's the best sounding damn Bassman I've ever heard. Where'd you get that? And then he gets to tell him the story. Oh man, my friend Brad, the Guitologist, went through this and fucking, you know, that makes me proud. It makes me proud to do this sort of work. And I hope you guys enjoy these sorts of videos. Now let's get this thing back to the owner and give it a test.
This is like my main guitar that I play out and stuff, you know. So
I like that case.
This dude's mom, sometime in the 70s, right? She did this for him. You know, he was in a band called the
Blue Jeans.
No, it was called the A Brother's Pride, and they were out with the Bee Gees and some things like that. And she covered his case up.
That is freaking cool.
Yeah, it's sort of kind of a piece of folk art, the case is, you know, just in general.
I love it. That's a great idea.
So this is pretty much, if you see me playing out, I'll probably play this guitar, you know.
That's sweet.
It's just...
Yeah, I've seen this on your videos before and stuff. Super cool.
Yeah. 65.
Love it.
3 patent number Humbuckers, patent number. Humbuckers. Not quite the ES, but they're basically the same thing.
Master volume on the back.
Right.
You see why you need it, right? Deep will just clean it right.
Right.
Just go to put your deep
So
on.
basically,
Because all the it's bleeding off a lot of the signal. And that's actually with this channel a little bit mixed in.
Yeah.
Now this. Keep playing. Basically, that's how I kind of recommend fitting your tone.
Fairly ruthless.
Just, I mean, go with set whatever tone you want here,
yeah.
and then if you want to mix in a little bit, just mix it in.
Yeah.
You can do this jumper thing, or you can get an ABY switch on it, and do the either or both thing, and this will be like kind of all you would need at that point, because you can jump, flip back and forth. This is a pretty bright channel here. What's that?
It's very quiet.
Well, it is now. I mean, now, maybe. There's a, yeah, I know. It's got nice power cord.
this guitar for a long time now, but the case is like
The case
the
is
thing.
something special. I've never seen anything like it. I love it.
Everybody wants to see the case.
That is so cool.
It's like, oh my God, what's going on with that case?
What is your Strat?
This is 58.
The 58 Strat?
58 Strat.
Nice.
Yeah. No, this sounds great, man. This sounds amazing, actually. What happens if we just play through the channels, just straight up?
Just this.
So that sounds just like the bass, like it was.
No.
Like a Bassman? No.
Well, close, but not quite.
So that the boost is on here, right?
The boost is off when it's up.
Right. So then it's pretty much just like a standard.
This is standard, but
Right.
the channel's not standard. The channel, I actually made it a little brighter.
You did.
Yeah. The thing is too, this is a transitional model between two different models. It's not an AA 165 or an AB 165. It's like transition. It took me a while to figure that out because I was going by the tube chart. I was like, oh, it's an AA 165. There's your Bassman.
Yeah, that sounds.
Yeah.
Sorry, this deep cornice pedal's kind of dark. So
No, that's.
Sounds mostly silent when it's not making any noise.
Yeah, no, it's not supposed to. Yeah.
Yeah. It's wonderful. So where's the master at right now? Like, do you?
It's low.
It's low. Yeah.
I mean, it being here, you're gonna have a hard. You'll just have to feel it.
Yeah,
It's right there and play. So that's all the way up. So that's basically stock. All the way up is stock.
Yeah.
It's
This
just
how
out.
it would be. Yeah.
Except you'll notice. Like you can go instead of going on 2 and being like full blast basically, and then just compressed gain after that. With the AUs, you can use your dial. But see, I'm also on the D. Take that off.
He has a question.
You gotta play the drums, Brad.
Yeah, I'd like to.
You should.
I think I'm gonna.
beautiful sounding.
Digging it.
Yeah, I
Yeah.
like that a lot. Yeah.
I mean, that's just pure tone.
Yeah.
You can add in this. You know, you just gotta mess with it.
Yeah, man.
Alright guys, that's going to do it for this video on the 1966 Bassman. I hope you guys have enjoyed this one. If you have, hit subscribe down below. Also, check out Bob Bradley's channel. He's got some good stuff on there, man. Check out his channel and give him a sub as well. If you want to see an extended version of the end demo where I stayed over at Bob's and pulled a bunch of stuff out of his closet, vintage guitars, vintage amplifiers, we looked at a whole ton of stuff over there, and it was a really fun day. I like to thank Bob for having me over and treating me so well. But I should have a video up of an extended jam session and stuff like that over at Bob's. If you guys want to check that out, it'll be up in a day or two. But for now, we'll see y'all later.